Hi, today I'll be demonstrating on optimizing complex RF design using Aiora Artemis, a product of FieldPower. When it comes to optimizing complex RF designs, there are usually three main challenges for conventional optimizer to overcome. First, the design accuracy. The more complex the design, the harder it is for optimizer to achieve its goals. Second, the computational speed. Complex designs usually requires more evaluations or iterations to complete its optimization. Lastly, there is also premature convergence. Many conventional algorithms out there struggle with premature convergence when the design is complex or when the component attributes are overly sensitive to tuning. Now let's take a look at this design. We have with us an 8-poles asymmetric bandpass filter. This is an extracted poles unit, or commonly known as EPU design. This design is complex because the design synthesis and coupling matrix cannot be achieved using conventional Chebyshev traversal array network. The asymmetric design is also significantly harder to optimize when compared to its symmetric counterparts. For this example, we purposely detune all the values of the transmission lines as well as the ABCD network. This is to make it even more challenging to optimize. Now let's take a look at the design response. As we can see here, the S parameter is completely deformed due to the detuning that is done to the design itself. Now let's proceed to perform the optimization using Aiora Artemis. Aiora Artemis is an AI-assisted optimizer designed to complement existing RF EDA tools. Aiora Artemis takes up the role of the optimizer to guide existing simulators in EDA tools to better perform the optimization process. In this example, Aiora Artemis will utilize the new Python API to achieve that with ADS using reinforcement learning. Aiora Artemis' main strength is in its ability to achieve greater design accuracy using lesser evaluations while lowering the risk of premature convergence. For this demonstration, we will show a previous optimization of the EPU 2D design. First, we load the design schematic inside Aiora Artemis. We select Keysight as the environment, open up the workspace, and point to the schematic that we want to optimize in Aiora Artemis. When the schematic is loaded, all the variables that is found in the schematic will be presented here as optimizable design parameters. We can also load the design response in this left panel here. Let's do a comparison. We can see here the design response from Keysight ADS is identical with the loaded design response in Aiora Artemis. We can now proceed to load a saved configuration settings for our optimizer. This config file will contain settings that are for the design parameters, the goals, as well as the optimizer settings itself. Design parameters that are set to optimize will appear as purple. Goal settings that are set will be represented in its respective design response as dotted and colored lines. For this optimization, we also up the total evaluation as well as to enable one of our latest AI technology, which is multi-agent optimization. I believe we are ready to start the optimization. When starting the optimization, Aiora Artemis will first establish a connection with Keysight ADS. During the optimization process itself, Aiora Artemis will utilize the Python API to call Keysight ADS to simulate for candidate solutions. All the iteration data and results for the optimization will appear in the table here. User can also see how the optimization is faring from an overview through the cost function report graph here. Aiora Artemis will also automatically update the best design response continuously as the optimization goes on. In this chart area here, we can also create our own custom report panel. In this custom report panel, we want to show the response surface side by side with the cost function table as well as the cost function graph that we see from the previous tab. This custom report panel gives us the flexibility to do resizing according to our liking. Now let's talk a bit about the response surface report. The response surface report is a unique way for Aiora Artemis to tell the user how the Aiora AI engine is converging on a potential solution. With each best response that Aiora AI engine discovers, it will appear as a dot in the response surface chart. In this chart, we will see the entire search space for the AI engine as the optimization is going on. We'll start seeing blue regions start appearing in the chart. When the blue regions start appearing in the response surface, it shows that the AI engine has discovered a potential breakthrough to converge on the set goals. Moving onward, we'll see that all the potential candidate solutions are all centered around this region. And we can see how the design response is improving and how the cost function graph is also starting to converge. The optimization has now ended. We have spent approximately 2 hours and 10 minutes to complete the optimization. We can see here that our cost that we achieved is equals to 0. This denotes that all the goals have been achieved for this optimization. We can also preview and apply data from different iterations by selecting them here. In this case, we want a design response with equiripple at the S11 for best performance. We see here the optimization that is done using the genetic algorithm in ADS on the same design. The optimization has prematurely converged with a time span of more than 9 hours. When compared with Aiora Artemis, we see that Aiora Artemis is able to achieve a cost function of 0 with all goals achieved with 3 to 4 times faster the speed. We also notice that Aiora Artemis is able to achieve a greater and more accurate design response when compared with the genetic algorithm. Aiora Artemis has the potential to address the 3 key main problems in optimization. Aiora Artemis is able to achieve better accuracy with lesser iterations and with a lower risk of premature convergence. Thank you, and until next time.